All right, folks. Happy Thursday. Today's Thursday. What is it? May 11th. Yeah. It's a nice day outside. So we are jumping in to chapter 5. We did a great job, um, jumping into, chapter 4, touching on a few things. Pretty fun going over the CLI. But now, this is where we get to the good part, the nitty gritty, right? The beginning of a long journey, right? Of, becoming a network engineer, right? And so, of course, you see the OSI model, right, on my screen, right? We talked mostly all the way up to this point about layer one, right? How to connect to a device, how to access CLI, the different types, what a switch is, a switch port, et cetera, et cetera. Now we're jumping to layer two, okay? The data link layer for, as far as OSI. If we're talking about the TCP/IP model, data link as well, okay? So it's still layer two, right? And so I want you to take a look at this, right? I'm sure you guys know what a router looks like. There is no router in this topology. What we have here is a LAN network, okay? Right? And on the left, we have a campus LAN or a campus local area network and a data center local area network, all connected via switches, okay? So I want you guys to read the top. Take the time to read the top, and I will read it with you. This is probably one of the most important things to understand when dealing with switches, switching in general, and routing and switching as well. Okay. So these are the three main functions of a switch. Okay. Again, I want you guys to remember. Number one, deciding when to forward a frame or when to filter, meaning to not forward a frame based on the destination MAC address. Okay. Preparing to forward frames by learning MAC addresses by examining the source MAC address of each frame received by the switch. And last but not least, my favorite, preparing to forward only one copy of the frame to the destination by creating a layer 2 loop-free environment with other switches by using spanning tree protocol. Okay, so number one is the switch's primary jobs, right? To go ahead and forward frames, right? Number 2 and 3 comes right with it. But these are the main functions. If you pull a switch out of the box and you put it in your network, these are the three things that it is going to do by far, right? And if we're talking about Cisco, it's going to do this. I know different vendors, you have to enable spanning tree, kind of annoying, but yes, this is it, okay? I need you guys to remember this through and through, right? The three main functions of a switch, okay? All right, so let's move on. I know in chapter 2, we touched on Ethernet data link protocols, right? And we discussed what a layer 2 frame looks like, right? The format or what have you, right? And so this is one variation, right, of a Ethernet frame, right? Again, Ethernet sitting at layer 2, right? 802.13, the IEEE standard. This is how it looks like. If you look at a packet capture, and we will soon during lab day when we're examining some layer 2 stuff, you will see all these sections exist within that frame, right? And I know you guys heard me say the term packet and frame. So they vary, okay? When we're talking about layer 2, the terminology is called a frame. When we are talking about layer 3, the term is called a packet. Okay? I want you guys to remember that. All right? A couple of things about a MAC address. Of course, it's 6 bytes long, right? 12 hex digits. I won't show you on my screen now because I don't want to confuse you. But when we get to the lab, you guys will see. Okay. So this is not really a key topic, but I need you guys to understand this because they will ask you questions on the exam. And just for the sake of troubleshooting when you in you guys' future. Okay. I need you guys to know this. So let me go ahead and read it with you, right? A switch's MAC address table is also called the switching table or the bridging table, or even the CAM table, right? The content addressable memory table, okay? In reference to the type of physical memory used to store the table. So that's in reference to the CAM table, okay? That definition at the end, okay? But we're going to keep it simple. We are going to call this, call the switches MAC address table, the MAC address table, okay? And this is in relation to the first part of us covering this chapter, which is forwarding known unicast frames, okay? So let's talk about this diagram, okay? And I want you guys to remember the three main functions of a switch, okay? And so let's go ahead and read this through and through, right? So we have four PCs and a switch. They're all connected, okay? So Fred is connected to port fast Ethernet 0/1. Barney is connected to fast Ethernet 0/2. Wilma is connected to fast Ethernet 0/3. And Betty is connected to fast Ethernet 0/4. I did not know the Flintstones had switches, right? Whole infrastructure, right? I didn't know, but I'm glad they did. Okay. So let's keep going. Okay. So Fred, right? Fred wants to go ahead and send a frame, right? The destination ends in .2222. Okay. And if we look at our diagram, who has that MAC address that's in that destination field? Barney. Okay. So let's talk about what the switch will be doing. Okay. And just remember, right, that action, one of the three main functions that I told you guys about, because I'm going to repeat it. One of the first actions that I spoke about is deciding when to forward a frame or when to filter, not forward a frame, based on the destination MAC address. Okay. So the switch, right? A frame came in on fast Ethernet 0/1. It is destined for .2222, and I'm saying the last four numbers, right? Forward out fast Ethernet 0/2, right? And filter do not send to fast Ethernet 0/3, fast Ethernet 0/4. Now you guys are probably wondering, how does it know about Wilma, Betty, and Barney, right? If a frame didn't pass through it. Okay. So we're going to talk about that later, right? And it has something to do with art, but we are going to just say the switch for this diagram has knowledge of all these devices in its MAC address table. Okay. So Fred, he sends it to the switch gets it and say, oh, okay, this is destined for this MAC address. I know what this is. This is fast Ethernet 0/2. It is going to send it to Barney. Okay. Let's keep going. All right. So we talked about that previous diagram, right? But what happens when we add another switch in there? Okay. So let's talk about this diagram now. So we have two switches, switch one and switch two. Okay. Wilma and Betty are on switch two, Fred and Barney on switch one. Okay. So same thing, right? Same thing. We have Fred trying to send a frame to .2222. Okay, which is Barney's MAC address. Okay, and so what's going to happen is the frame is going to go ahead and enter fast Ethernet 0/1, right? It's destined for .3333, right? And the MAC address table entry is for gigabit 0/1. And let me go ahead and make a correction. It looks like, and again, you guys will see this with some Cisco documentation and some Cisco books. I took this picture out of the Cisco book, right? Sometimes they do make errors, grammatical errors with their writing. So by looking at this diagram, it looks like they meant to say the destination is .3333. Okay. So just keep following along with me and what have you, and don't be alarmed. So Fred is trying to send this frame to Wilma. All right. So let's talk about that process. So the frame entered fast Ethernet 0/1 is destined for .3333. Okay. And so when switch one looks at the MAC address table and it says, okay, where is .3333? Okay. Oh, okay. It's off of gigabit 0/1. Okay. So switch one is going to make that decision and forward it out gigabit 0/1. Okay. Which is going to send it to switch two. Switch two is going to say, okay, I got the frame. It's destined for .3333. Okay. I need to go ahead and forward it out of fast Ethernet 0/3. Okay. And this is how it looks, and this is what happens whenever um, frames are sent via a link between two switches. Okay, we're going to talk about trunks or what have you in the future, but this is how it looks forwarding between two switches. Okay, of course, what I told you guys, of course, that process. Okay, and so let's go ahead and touch on this. Okay, let's go ahead and take a look at how that MAC address table is being built. Okay. And so Fred, right? Fred is here, right? Fred is trying to send a frame out, right? He's trying to send a frame to Barney, right? And so Fred sending it to the switch. Remember, the switch learns MAC addresses, right? Based on the source MAC address. Okay. Received by the switch, right? So as soon as Fred sends that, he says, hey, I need to go ahead and send something to Barney. That MAC address table is going to populate and say, hey, I know where Fred's MAC address lives at. It lives off of fast Ethernet 0/1. Okay. What the switch is going to do, switch doesn't know, and doesn't know about where Barney lives at. It's going to send a broadcast, right? A broadcast message, and we'll talk about that in depth in the future. And we'll talk about forwarding unknown unicast frames in the future, right? But this is just a precursor, right? He's going to send a broadcast and say, hey, who is this is destined for .2222, right? Who is it, right? And it's going to be sent out all ports except for the port that it received the frame on, which is fast Ethernet 0/1. So it's going to be sent out to fast Ethernet 0/2, Barney, fast Ethernet 0/3, Wilma, and fast Ethernet 0/4, which is Betty. Barney is going to be the only one that sees it and say, oh, this is me. So Barney's going to go ahead and send a reply and say, hey, Fred, this is Barney. This is where I'm at, right? But what happens within the switch? Okay. Remember those three main functions of the switch. Barney's going to send that frame towards the switch, fast Ethernet 0/2. The switch is going to say, Barney lives off of fast Ethernet 0/2, and here's his MAC address. Let me go ahead and log this into my MAC address table because, again, one of the three main functions of the switch, right, which is number two in that PowerPoint in that slide that I showed you, right, is to prepare to forward frames by learning MAC addresses by examining the source MAC address of each frame received by the switch. Okay, so now the MAC address table has populated, right? And so now the MAC address knows where Barney is and knows where Fred is, right? And when Barney is sending that back to Fred, the switch automatically knows because it's logged in that MAC address table. Boom, I know where Fred lives. I don't need to go ahead and send a broadcast to all ports because I know where he exists. Okay. With that being said, we are going to stop there. I even felt myself getting excited. I'm sure you guys can see I'm a little bit louder. But again, we are still at layer 2 and we are not done. Okay. I hope all of this made sense. Please read chapter 4, right? Please read chapter 4. It's very important so it can make sense. Okay. I know I touched things at a high level. I know I touched a little bit of low level talking about some technical stuff, but the next session we're going to talk about flooding unknown unicast and broadcast frames, right? I just want to give you guys that precursor today. Okay. Well, thanks guys for joining, and you guys have a great day.